Hi, welcome to my video on bisect a segment and an angle using a ruler and a compass only, no protractor. Bisect the segment AB. We have a segment here AB and we're going to bisect it. So we're going to take the compass, put it at B, and we're going to take the radius of the compass, because from tip to tip is a radius, because the compass is used to draw a circle. So at B, I'm going to open up the protractor to be more than half the length of AB. So let's say that's the middle. So open it up a little bit more. It doesn't make any difference how far you go, just to be reasonable. And so we're going to draw an arc using our compass. So here's the arc. Now we're going to place the compass at A, which is the other end of the segment, and we're going to draw another arc so that the two arcs intersect. There it is. The two arcs are intersecting. Move my hand so you can see it. Now I'm going to draw a line from one arc to the other. So the two arcs from the two intersecting arcs. So the arcs intersect here and here. So I'm going to draw a segment through those two intersecting arcs, 2 points. There it is. So that means that this segment will bisect AB. Now, to measure that, I can do it two ways. I can use a ruler to measure. That means that this point here is the midpoint of AB. So that means if that's, as you can see, that's 20 millimeters or 2 centimeters, and that's the same. So this segment is bisecting AB into two equal parts. Another way you can do that is place the compass at the midpoint and place it at A. So that gives you the distance. So swing it around, and it should go through B. So it's going through B and it's going to C. So that means that this point in the middle is the midpoint. So this is a bisector. This segment bisects AB into two equal parts by doing these arcs. Now we have number 2, the perpendicular bisector of AB. Well, we're going to do the same thing, only we're going to call it a different name. So we're going to place the protractor at Y. And again, we're going to open it up so it's more than half the, so if the length of XY, whatever the length is, I'm going to go more than half. So again, there's half. If I go less than half, the arcs from X and Y will not intersect. So let's go more than half. Let's go over close to X, and we'll draw an arc. So here we go. Now I'm going to draw the arc far enough up and down so make sure that they intersect. So place the compass at X, and with the same radius, draw it. So now I don't have to go all the way around. So all I got to do is just do this. So it intersects right here, and it intersects there. But if I want to go all the way around, you can. So we draw this segment, joining those arcs where the arcs intersect. So there's one point where they intersect. This is the other point where they intersect. So lay your ruler down and join them up. And we have this segment is now, not only is it a bisector, not only is this the midpoint right here, but this segment is the perpendicular bisector. Same as this segment. This segment here is bisecting it, but it's also the perpendicular bisector. And again, to show that, you place your compass here and you move it. There's the distance right there at X. So when I swing my compass, I should be able to pass through Y. And there it is. So that's the midpoint. And there's a right angle there. Now, I didn't draw the bisector, perpendicular bisector. I drew the perpendicular bisector with a compass. But I'm going to check the angle by using a protractor. So I constructed it with a compass, and now I'm checking with a protractor. And as you can see, they're right straight up through. This angle is 90 degrees right here. Okay, now we're going to bisect the angle ABC, number 3. So this is angle ABC. So to bisect this angle, we take the compass and we put it at the vertex of the angle. So the vertex of the angle is B, so place the compass at B, and we draw an arc. So we draw an arc, and it don't make a difference how open the arc got to be, or how much radius we have, as long as it's a reasonable distance, and we'll cut the ray AB and cut the ray CB. So this arc cuts both rays right here and here. So this distance from here to here is the same as this distance from here to here. These two lengths are equal. So we take the compass and we make sure that from this point to this point right here, we make sure that it's not going to be, so take this segment from, this is the segment. If you have a segment drawn from here to here, you make sure that this opening on the compass is more than half, because again, like here, if you don't, they won't intersect. So what I do is I go to where A is and I make my arc. So this is more than half the length. If I drew a segment from here to here, then I would take the radius of the circumference, that length, or greater. So let's open it up a little bit more. So here it is out there. Don't make any difference as long as it's more than half. Again, if you drew a segment from here to here, then this is more than half that length. So we draw an arc, and then we put it at A, and we draw an arc. So as long as these two arcs intersect, then we take a ruler and we join from B out to those arcs. So there's B, there's the arc. So we draw the ray. So there it is. So that means this segment. So if you want to name this segment, if you want to put an H here, then BH is the bisector of angle ABC. And to check that, what we'll do to check it, we'll check it with a protractor to see if it's bisected. So let's place the protractor at the vertex, and we measure the angle. So it depends. So it looks like it's about, give or take, depends on how we line it up, about 24 or 25 degrees. So we move it over, we get 24 or 25. That means we're going to check to see if angle ABH, this one is roughly 25, CBH is 25. So what is ABH? So we place the protractor at B again along this ray, right there it is, and again we line it up. So again, you got to be dead on. But again, it's we're approximating. So again, as you can see, it's 20 each time I measure if I'm not completely on. So that's a 24, and so we do this one. What do we get? And we're going out through there. We turn it around. Again, it's an approximation because my width of my pencil and things like that throws it off. So again, I got about, as you can see, about a 25, 24. So these two angles are equal to each other. So this angle right here is equal to this angle here. Let's be bisected. Now, we have another one. Bisect angle PQR. So this angle, this time, notice that this angle is less than 90. We bisect. This angle is greater than 90, so we're going to bisect it. So we place the compass at Q, its vertex, and we draw an arc to cut both rays. And again, the opening distance, you don't have to go way out like that, but we have to make it reasonable. So we bring it in and cut there. Now I can go all the way around, or I can just do this. So it's my choice. But if you want to go all the way around, so that means that, let's mark this time. That means that this is QF, and this is QH. That means because this is circular, that means that QF is equal to QH. So we place the compass at F and H, and the radius got to be greater than half of FH. So there's FH. So obviously the distance that I picked on the compass is greater than half the distance. So there it is, greater than half, almost up to F. So we place it at H and draw an arc. And we place it at F and we draw an arc. And the two arcs intersect here. So now we take a ruler and a pencil and we join them up. So when I join the place where the two arcs meet, down to Q. So this, and again, I'll name this as an X. So that means XQ is the angle bisector of PQR. So that means that this angle right here is equal to this angle here. And we use our protractor to verify that. Let's see. Place along, again we're going up this way, see, we're going up this way. So place it there, and we measure, and it looks like I got about, as you can see, 10, 20, 30, 40, 50, 55 degrees. So if I place it over here, I should get close to 55, if not. There we go. And there's the angle right here. So 10, 20, 30, 40. And again, it's just a little tweening. You can see it's close to 55 because I'm not laying it on perfect, but I could adjust it. So you can see it's close to 55. So that means these two angles. That means this angle must have been 110. Let's see. The original angle that I bisected was 110 degrees. So you can see this angle rotating up, and you can see 110. So this angle, RQP, is 110. These are 55 each. And right here, we measure this one. That one is around, again, if the line was extended out, probably around 50, so they're 24, 25 each. So you can see that these ABH and CBH are equal. We bisect the angle. Now we have a couple more problems to emphasize that. We have triangle FH, triangle FHT, such that FH is 4, HT is 3, and FT is 3. Construct the angle bisector of angle T to intersect FH at A. And then when we get that done, we'll say that TA is also, and we'll fill in this after. So what we have to do, we have to draw, notice we have here two sides equal. So I'm going to draw FH first. FH is 4 centimeters. So let's go right here and mark off more than 4 centimeters. So we go like that. Now I made it more than 4. I'm going to pick a point on this right here, right there. And now I'm going to use my compass. I could use my ruler to mark off 4, which is like this, as you can see. So 10, 20, 30, 40. So there it is there. Or I could use my compass, place my compass at 0, which is right there. And again, this is approximation. And so there's 40 marked off right there. So place the compass at, moving it right here. And you can see that I have the same mark. So there's 40. So we mark, that's FH. So we mark that as an F and that as an H. Now we got to draw HT as 3. So now we take our compass and we got to mark off 3. And that's, again, my units are in centimeters. So I'm going to mark off a 3. So put the compass right there at the end. And we'll move it in to mark it a 3 right there. So there's 3. So it says HT. HT is 3. There's H. So we mark off, again, anywhere on this arc that I'm now drawing, the distance from H to any point on this arc right here, any point on this arc is 3 units. And also, FT is 3, so I didn't have to move my compass. FT is 3. So any point on this arc that I'm now drawing, any point on this arc is 3. So take it away, and I join it up. So there's the 2 arcs intersecting. Right there is, and there's the, so this forms the other side of the triangle. So this is 4, this is 3, this is 3, and it says that the triangle is FHT, FH, so this is T, the intersecting of these 2 arcs. Now, we have that done. Notice the triangle is 2 sides equal, so it's isosceles. It says construct an angle bisector of T to intersect the angle bisector. Will bisect the angle coming down here to intersect FH at A. So let's construct the angle bisector like we did just in. So we place our compass at T and we draw an arc to cut TF and TH. So I'm going to draw an arc. I'm going to bring the compass in, make it smaller so we don't have big arcs all over the place. So I'm going to draw an arc to cut FT and HT. So this is the arc that we cut off. So that means this distance from here to here is the same as this distance from T to here. So we take this point and we make sure that the radius of my compass from here to here is more than half the length of this segment right here. So put the compass there, and that's more than half, so we make an arc down here, and we put it right here, and we make an arc, and so now we'll join, so T, so let's join this up, T to where the 2 arcs intersect. There it is. So that means that T, so this is going to intersect, it says it's going to intersect FH at A. So this is A right here. So intersect perpendicular, the angle bisector, intersect the arc right here at A. So that means that TA is the angle bisector, but also, if you notice, that if we measure, we take a ruler and we measure, that's an angle bisector, but it looks like that's a right angle. And let's see, it looks like that's 2 centimeters or 20 millimeters, and that's very close. Not going to be exact, but because there's 20 millimeters or 2 centimeters there. And you just use the protractor to see if we have a right angle. Let's see, right at this point, we line them up, and we can see through, it's going right straight up through here, so there's a right angle here. So there's this is an angle bisector coming from this, what we call the apex angle in an isosceles triangle. These 2 sides equal. So if you draw an angle bisector here, that angle bisector would also be an altitude because that's a right angle. And that angle bisector would also be a median of the triangle. So this segment drawn from T to A right here, that's all 3. In other words, it's an angle bisector, it's an altitude because it's perpendicular. It's an altitude because if a segment is drawn from a vertex perpendicular to the opposite side, it's an altitude. And this is also a median. So it's an angle bisector. So TA is an angle bisector because it bisects the angle. So this angle right here is equal to this angle. And this is an altitude because it's perpendicular. And this is a median because it goes to, if you measure these, that's 2. And that's 2. So the A is the midpoint. So that means this is a median. So A is a midpoint, so this is a median. And in relation to, oh, I don't have it marked in relation to its F, that's supposed to be an FH. This segment is also in terms of this segment, it's also called the perpendicular bisector. In relation to the segment, it's called the perpendicular bisector. So this segment is perpendicular to FH and it bisects SH because it's going through the midpoint, making these equal. So just wanted to, again, more constructions and more math that in these constructions. Number 6, a triangle ABC is the right isosceles with angle B 90 and AB 4. Construct the perpendicular from B to AC intersecting at T. And then we got to find the length of these segments. Well, again, what I do sometimes is to draw a simple picture first. So I have a right isosceles triangle. So an isosceles triangle, a right triangle has a right angle. And an isosceles triangle has two sides equal. The only two sides can be equal in a right triangle are the two legs. These are the two legs that form the right angle. This is the hypotenuse. So we have a triangle with angle B. So that's angle B right there. And A and ABC, A and C, that could be A, that could be C, vice versa. And it says that AB is 4. That means if this is equal to this must be 4. So we have to now continue. I'm going to draw this diagram. So we have to, it says AB is 4. So the first thing to do is to draw a segment. Here we go. Let's draw this segment. Make it longer. So I could put a point down here. And I got a choice. I can put, this is, if I say I want to draw my right angle, so if I make this my B is going to be my right angle. So I'm going to construct a perpendicular here, but I'm not allowed to use a protractor. I have to use a compass. So to do a right angle at B using a compass, then I take my compass and I open it up. So it has to intersect the line. So there it is intersecting. So if I extend this line over, I could use a ruler, but I'll just do it in hand right now. So there it is extended. So if I want to draw a perpendicular from B, perpendicular is going to come up here. So again, I put my compass at B and made an arc. So I put my compass at these 2 points right here. I'll open it up to be greater than half. That's a half. So I'll open it up to be more than half. So there it is. Out. So draw an arc up here and put it right here. We did this previous. So there's the two arcs intersecting. And as a result, I use my ruler. Take the ruler here. I will draw a perpendicular. So I constructed a right angle that we learned just then. What you learn in constructions will be used over and over and over. So there's the right angle. So there's the right angle at B, 90-degree angle. Now, AB, so I can put AB here if I want. So I got to mark off 4 centimeters. So I take my ruler and mark off 4 centimeters. So here we go. Put it, so you can hopefully you can see it. There it is. And mark off 4 centimeters. So there's 40 millimeters is 4 centimeters. So move my ruler. Now keep it steady. And so AB. So there's B. So I got a choice. I can either swing it here or I can swing it here. It makes no difference. AB. So let's do the original. Makes no difference as long as that's 4 centimeters. So this one is longer, so let's cut it off here at 4. So that's 4 centimeters. That means that's B, which is the angle. This is the A. Now, that's AB is 4, that's angle A. So that means that if AB is 4, BC got to be 4. So we take the same distance we just had and put it at B and mark it on the other line. So there it is there, 4. So it's 4 there, as you can see, that goes right around forming this arc, which is on the circle. So I didn't go far enough, so I take my ruler and I extend the segment up to hit at 4. So there it is. So that means this is 4, and this is 4, and this is my right angle. So I need to make a triangle. It's a right triangle, and it's isosceles, two sides equal. So let's make a triangle from here to A. So that's C, that's A, that's B. So we got BA 4, BC 4 with a right angle. Now, that means this is the hypotenuse right here. Now, it says construct a perpendicular from B to AC, intersecting AC at T. So how do we construct a perpendicular? Well, we use our compass, and we take our compass. It got to go from B to AC. So there's the B. So put our compass down. And remember, now it's intersecting here twice. So I could use, if I wanted to, I could use this arc. I already have my arc there. So I got it here and here. So I could use this arc, or I can shorten it, the distance, and draw a smaller circle with a smaller radius. But let's use the arc I already have there. And so again, I got to be greater than half the length of AC. So there's half of it. So open it out, greater than half the length of AC, and we draw an arc. So one arc is right there, and we put it at C, and we draw another arc. And notice I just did it. So let's go back and make it so you can see where it's intersecting. Here it is. So now we join up. So we drew a perpendicular on the two of these arcs. So there's the perpendicular so this is the perpendicular from a point not on the line. So this is the perpendicular right here. That's a perpendicular. And again, to check that perpendicular, we put the compass down, line it up right on there, and you can see again that it's very straight on through, so it's a 90-degree angle. So that's a 90 there, that's a 90 there. And it's intersecting at T, so this is T right here. This is where the perpendicular cuts AC at T to form the right angles. Find the length of TA, TC, and TB. So of all three of those, let's see, let's take TC. Let's see what, again, notice that these two sides are equal. So this is an isosceles triangle coming here. So that means that BT is going to bisect these angles. They're going to be perpendicular to this side, and they're also going to be a median because this is the midpoint. So that means that TC, there it is, TC right there, TA right there, and TB. So notice that TB, TC, and TA are all equal. But it says find the length. So we'll take a compass, take a ruler, take a ruler and measure. So I have approximately around 27 or 28. So let's take it and see what we have here. Again, as you can see, 27 or 28. That's, I'm doing millimeters this time, which is 2.7 or 2.8 centimeters. And let's check this one. And again, we got 2.7 or 2.8. So they're all the same. So it's 2.7 or 8. Each one of them is the same. because this is an isosceles triangle with 4 and 4, no matter what I draw from this vertex angle, being those congruent sides, if that goes down through the middle, then we have a right angle. We have an angle bisector, because that angle there is going to equal that one. And this is going to be the midpoint, the median. So that's going to be perpendicular bisector. This is the perpendicular bisector of this segment. Okay, and it's also an angle bisector. So again, just check. This is an isosceles triangle, so that means that these two angles are going to be equal. If two sides are equal, two angles are equal. So that's a 90. This is a 45, and this is a 45, because 180 is a triangle. And let's check to see if this angle is 45. Okay. Now it should be, I should have a 45-degree angle. That's if I made, did I make this one, did I make that one 4 long? That's the key. A little bit off, yeah, that's 4. And that's 4. So that should be 45 degrees, because that's a 90, and these two are equal. These should be 45. Let's check this one. Hey. Oh, sure, I was putting it on the wrong. Look at me. I was putting it right here, putting this point here. I had to go up to the middle. I was wondering why I was off a bit there. 45. So this angle is 45. So let's check this one. Put it right here. I was wondering why I was off. So here it is, going through 45. I had to have this point right here, pointed with a pencil. I had to have this point here right on the vertex of the angle. So they're 45s. Okay, and we have another one. We have a triangle PQR, where PQ is 7, PR is 5, QR is 5. It says construct the angle bisector of R, the altitude from R, the median from R, and the perpendicular bisector of PQ. Okay, well, let's take a ruler and we'll draw a segment. Let's see. Let's see. Let's draw it right here. Okay, there we go. I just made it longer. So again, we can go from, take this point, and it's PQ. So what I'm doing, I got a triangle PQR. So I just draw, there's no angles given, so triangle PQR. So I can go PQR. So PQ is 7. PR is 5. And QR is 5. So that's the triangle I want to draw. So I can take the 7. I'm going to do PQ first because that's the longest one. So I'm going to go from, let me show you, right there at 0 on up to, it's all moving on me now. If you had this felt, so there's the 7 right there. So that's 7 centimeters long. So PQ is 7. So there's PQ, 7. Now I could have taken a ruler because the initial length could be done with a ruler. So I could put a ruler here and mark off 7. So it is 7. Now this is P and this is a Q. So now I have to mark off PR is 5. So when I do the second one, I need to do the compass. So I need to do a PR. So there's the, right at 0. 5. 5 is right there. Let me move that back. 5 is there. So PR is 5. So there's 5. So it says PR, put it at P. PR is 5. There's the arc. And it says QR is 5. So there's Q. QR is 5. So R is out right here. So R is right here. So we'll join that up, and we'll have the correct triangle. You got to be careful. Right triangle, correct triangle. When I say a right triangle, I don't mean that as a right angle. I just mean this is the correct triangle drawn. The specs. There it is. So I got QR is 7. I got PR is 5. And I got QR is 5. Now, it says construct the angle bisector of R. The angle bisector. So the angle bisector, I have to bisect angle R. So I put the compass at R, and I make the radius so that I cut. So I'm gonna, there's the compass at R, open it up to cut RP, done, and RQ. So I could go all the way around like that, but I just don't want to make it confusing. I just want them, I could, if you want, just watch, do all the whole arc. Now I want to bisect. So I have this segment from here to here and from here to here are equal because they're on this arc. So I place my compass, as long as it's, again, the distance that the compass has to be is greater than half the length of the segment that goes from here to here. So I put it here, is more than half, so I make an arc, and I go right here, and I make an arc. So when I draw this segment from R to those two arcs intersecting, I have, this is the angle bisector. So that angle equals that angle. Take your compass and measure it, and you'll see that the two of them are going to be the same measure. Now it says I got this one done. Now I got to draw the altitude from R. So the altitude, that's going from a point not on the line. So there's R. So I opened up my compass to intersect P and Q at 2 points. So there it is. So I'm opening up the protractor to intersect P, Q at 2 points. So there's the 2 points there and there. So my radius up, as long as it's more than half, remember the segment from here to here, I got to be more than half of this. If I have less than half, they won't intersect. So I go here, and I go here. So I'm doing the perpendicular from a point. So I'm drawing an altitude from here to here. So that means I did cut these arcs, and they're intersecting here. So there's this one to R. And as you can see, what's happening? It's just a little bit off here. It's just extending on. It's the same line, same segment. Why? Well, you can see that that's a 5 and that's a 5. Again, these are the congruent sides. So when you draw what? An angle bisector, it becomes an altitude, so that's an altitude, so that means that's perpendicular here. That's a right angle. And again, you can use I've used my protractor, and I can see it's a right angle. Well, just want to show, make sure, there it is laid out. There's your 90 right straight up through. Okay, now we got to draw a median, and a median goes to the midpoint. We got to draw a median from R. So if a median leaves R, it's going to the midpoint of PQ. So to get the midpoint of PQ, I got P and Q. I have to open up my compass more than half. So here we go. So there's halfway. So I have right here, that's halfway right there. So I have to open up more than half. So here we go. And we draw an arc. There it is. And I have to put it at P with the same radius on my compass and draw another arc. And so, as you can see, the two arcs from Q, this is this arc, and from P, it's this arc. So the two arcs are intersecting here and here. So what happens when I draw that? Join them up. Right along, again, it's a little bit off, but it's right along the same line. So that means the median drawn from R to this midpoint is making, this is a median, because this segment right here, if you mark that as an M, then QM is equal to PM. So that means these are equal. So that's a median. So yes, this is an angle bisector. This is an altitude because it's perpendicular. This is the median because it leaves here and goes to the midpoint of the opposite side. Because it's a bisector, an angle bisector, it's an altitude of the median. And also, because I drew this arc, this is also a perpendicular bisector. Why? Because it's PM is equal to QM. Let's just measure it to see. Notice we have, well, another way I can measure it is take the compass and put it at M and go to P. So if it goes through P, it should go through Q. There it is. That distance there from M to Q is the same distance from M to P. So those distances are equal. So that means that's the midpoint. So that means that this segment is not only a bisector cutting in half, but it's the perpendicular bisector. So I wanted to show you some constructions and how to use the compass and the ruler and different ideas. But this is perpendicular, bisector, bisect an angle, bisect the segment. And if you like my video, click the like button, click the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Notice one word, Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.